Fourier series, session 5. This we are going to consider in this session problems on Euler's formulae to determine A0, An and Bn. Now let us take the problem here. Expand f of x is equal to x square. F of x is equal to x square is our function. In the interval minus pi to pi, x is ranging from minus pi to pi in a Fourier series, and hence deduce that we need to deduce into two forms. One is 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus etc. is equal to pi square by 6. And the second one is 1 minus 1 by 4 plus 1 by 9 minus 1 by 16 plus etc. is equal to pi square by 12. Now to solve this problem, first let us consider our function. What is the function? We have f of x is equal to x square. Now let us try to solve the first case. Let us try to solve the first one. Now we know that f of x is equal to x square. Let us find out whether this function f of x is equal to x square is an even function or an odd function. So when I take f of x as negative, that is minus of x, what do I get? I get back my function x square again. So therefore we know now the function f of x is an even function. We know if a function is even a function, what do you know? That Bn is 0, and we need to determine only A0 and An has to be determined here. And we know that what is A0 and An that we have to determine? What is it? A0 is 2 by pi because it is varying from pi. Pi is the varying. So integration from 0 to pi f of x dx. That is 2 by pi integration from 0 to pi. We know f of x square dx. Now integrate x square. What do we get? 2 by pi x cube by 3 between the limits 0 to pi. So it is nothing but 2 by pi into applying the upper limit minus the lower limit. So it is pi cube by 3 minus 0. So we end up by 2 by 3. Pi gets cancelled, so pi square. 2 by 3 pi square is the answer. That is my A0. So if I take, let us now find out what is An. What is An? It is again 2 by pi integration from 0 to pi fx cos nx dx. So what it will be? That is 2 by pi integration from 0 to pi f of x is x square cos nx dx. Now what we have to do? We have to use the integration formula. That is integration of u dv is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus etc. It goes on. So let us consider this. So in this, u is x square, dv is my cos nx dx. So it is differentiation and integration. First integration, second integration, third integration goes on. So now let us write this expansion 2 by pi. It is going from, what is u? U is x square. What is the integration of cos nx dx? Will be sin nx by n minus differentiation of x square is 2x into again the integration of this term sin nx by x. It will become cos minus cos nx by, already one n is there, because of integration we get back one more n, so it becomes n square plus, now double time integration, 2x integration will be 2, and integrating this once again we get minus sin nx by n square, and one more integration we get from the integration one more n, so it will be n cube minus integration of 2, the third integration will be 0, so remaining terms will be 0. So we need to consider only them. So now what we have, this is from 0 to pi. We know since we have integrated, the integration is from 0 to pi. So now that is equal to 2 by pi. Since when we substitute pi, this becomes this whole term, whether you take pi or 0, this whole term will be 0. Pi or 0, this whole term will be 0. So we are left out with what? Minus into minus plus 2 pi cos n pi by n square minus, this is upper limit I have applied, minus If I consider cos n, cos 0, 2 into 0, the whole term becomes 0. So minus the whole term becomes 0 here. So what is this? When I multiply, 2 2s are 4 cos n pi by n square, or it is 4 by n square into minus 1 to the power of n will be the answer. So this is what this is my an coefficient. An I have found out, because you know cos n pi is minus 1 to the power of n. Now the Fourier series. Fourier series, you know what it is? F of x is equal to what? A naught by 2 plus summation n is equal to 1 to infinity an cos nx dx. So this is the answer. We know that. Now let us substitute. We know what is f of x. X square is equal to, in the previous case we had found out a naught. A naught was 2 by 3 pi square. So if I take this 2 to the other side, I will be getting a naught by 2 is equal to pi square by 3. So let me use this. A naught by 2 is equal to pi square by 3 here. So it is pi square by 3 plus summation n is equal to 1 to infinity. I have found out an. An is there. An is here. So it is what? 4 by n square and minus 1 to the power of n into cos nx. So this is what function fx. Now to deduce the series, I have to deduce the series, right? So let me put use the series. Let me put x is equal to pi. I will get it as pi square is equal to pi square by 3 plus summation n is equal to 1 to infinity 4 by n square minus 1 to the power of n into cos n pi. So cos n pi is again minus 1 to the power of n. So let us substitute that here. So we are remaining with, that is equal to pi square by 3 plus summation n is equal to 1 to infinity 4 by n square minus 1 to the power of n into minus 1 to the power of n. So if I take this pi square to the other side, I get pi square minus pi square by 3 is equal to summation minus n is equal to 1 to infinity 4 by n square minus 1 to the power of n plus n. That will be 2 times n. 2 times n means this whole thing is positive. We will get the positive value, and here we will take the LCM. 3 pi square minus pi square is 2 pi square by 3. You are going to get 2 pi square by 3 is equal to summation n is equal to 1 to infinity 4 by n square. So 4 is a constant. We can take it to the other side. So you are remaining with what? 2 pi square by 3 into 4 is equal to summation n is equal to 1 to infinity 1 by n square. So it cancels. So I am having pi square by 6 is equal to what? Summation n is equal to 1 to infinity 1 by n square. So 1 by n square, if I substitute, what do I get? 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus etc. will be equal to pi square by 6. Now second case, to deduce the series, in the second case, what I am going to put is, put x is equal to 0, the equation. So if we put x is equal to in the equation, what was that equation? That equation was x square pi square by 3 plus summation n is equal to 1 to infinity 4 by n square minus 1 to the power of n into cos nx. So here it will be 0 is equal to pi square by 3 plus summation n is equal to 1 to infinity 4 by n square minus 1 to the power of n into cos 0 becomes 1. So now if we try to expand this function, what I am going to get? 0 is equal to pi square by 3 plus 4 is a constant. Let me take it out. And this term is negative for odd and positive for even. So it becomes minus 1 plus 1 by minus 1 by 1 square is 1 plus 1 by 2 square minus 1 by 3 square plus 1 by 4 square. For even it is plus and for odd it is negative. It continues. So if I shift this, the whole term to the other side, and so what I am going to get? This whole thing 4 into the negatives becomes positive and positive becomes negative. So it is 1 by 1 is 1 minus 1 by 4 plus 1 by 9 minus 1 by 16 plus etc. continues is equal to pi square by 3. Shift this 4 to the other side. So I am getting remaining with 1 minus 1 by 4 plus 1 by 9 minus 1 by 16 plus etc. is equal to pi square by 4 into 3 in the denominator. So we have arrived at this answer. So these are some of the problems that we have worked it out. Thank you.